All right, finally pulleys. Okay, we're starting with this over here, which this is the pulley section slash cable and friction. So it's going to be a little bit, that. So first we start with this section. We know that we're dealing with pulley. This also must be T. This is a common practice where the whole thing must be equal because it's all frictionless. If it's all frictionless, if it has friction, then we are a little bit interested. But if this is A and this is going down to 1 and like this, is T1 over here, T1, then this is 2T1, okay? And then we go to B, and then we must do another 2T1 over here. It's the same thing. And we must do C next, and C must have, this has must T1, C has 4T1 over here, and then over here, interesting enough, we need to balance it over here for T1, assuming gravity doesn't matter. A to T over here, and then basically this log now has the combined thing of 8T over here and a 4T1 over here. So if you have a summation of Fy equals 0 at the bottom because it's still static. We have 8t plus 4t that's positive, and then that must be negative 1200 newtons equals 0. Therefore, it's 12 newtons equal 1200, which you can guess it is 100. That's a very powerful pulley mechanism. Do I like pulley mechanism? It can get hard when adding friction. So the next question definitely has a more oomph to it. The difficulty is it really expands very fast in it. This one you need to realize what is going on. So, hmm. So problem 2 and 3 refers to this. Okay. So what's happening is it's a brake arm. So it's hitting over here. So what is this looking for? The static coefficient of the drum is okay. So this is actually the big. 30 is the big one. 10 is a small one, by the way. The coefficient of friction between the brake pad and the drum is 0.2. So over here is 0.2. Notice that is 0.2. And the brake drum and okay, so it's weight over here. So it's just um no way. It's identical. Yeah. So you get the whole point over here, what's happening. And basically when the brake is on it, you have like a certain force on this and what is trying to be found. Assume the support, what can W be realistically is trying to be found over here. Now, here's a trick. This over here, and there must be a friction, so it's going, let's assume a friction force this way for now. FFR, and this can be a normal force that we assume, and this can be 100 newtons, and then this is AY and AX. So we clearly can start somewhere from here, right? Summation of moment at A is probably the first thing you thought of because we can get rid of FR and the buggy we can get N basically. So if it's 1.5, we can do summation of MA equals 0 globally. And then we can say um, 100 multiplied by 3, that is positive, minus, well, we did positive and then minus this way. So minus N multiplied by 1.5 equals 0. So N equals 1 divided by 1.5, negative, parentheses negative 300. And that in your calculator should get you something. Negative 1 divided by 1.5 multiplied by 300 equals about negative 200 newtons. Okay, that's beautiful. So that gives you a place to stand. So 200 newtons over here, negative wise. Oh, sorry, positive, because negative, so this is actually positive. My apologies on that one. Okay, so it's positive, so I was right. I was like, weird, that doesn't make any sense. It should be positive. Anyway, with that said, we can now do something called get friction. We know what friction is because we can just say if this is the direction of friction, because it should be because you're moving that way, right? Which actually direction is it moving? I don't really know. Yeah, I actually don't know. Fun fact. Uh, Now, if I choose that direction, then the responsible other direction is going to be this, right? And is there any rigidity to RO or any chance by that manner? Yeah, there should be. There should be a force this way, I guess, and a force this way. Yep, and that should be it. Um, yes. And I think we should focus on body A first and get the brake paddle here. So from this excursion, you can treat this as actually a brake over here, brake over here, brake over here. So like, you know how we did inspection internally previously? So this is what's happening. We're doing inspection internally. So what that means is friction R is equal to mu and multiplied by 200, right? So that's 0.2 multiplied by 200, which is, oh wait, is it 0.2? 0.2. I Shiz Louise. of finding these mistakes here. The reason I have to look at the original question is because there's like a bunch of mistakes here, and I have to go around fixing them. 0.3. I wish they would fix themselves. They don't. All right, 0.3 is the actual number. So that's that we can like bold this out maybe. Um, bold underline 0.3. And maybe we can do a plus plus. Okay. Maybe we can like do this. We can just highlight this a little bit. White, fill in. How do you fill in again? Fill in white and then order backwards, and then we can do it like that. Yeah, that's great. So 0.3, I knew something was off. All right, fit again. So 0.3, and then on 0.3 multiplied by 200 equals about 60 newtons. So FFR equals 60 newtons. With the 60 newtons you have, we can go to this one because there's a second cut here, and we're going to do a moment diagram on O equals 0. And with that, we know this can have 60 newtons, right? And this is 200 newtons, right? And over here, we find that this weight is W, so this distance over here is 10, I believe. So we can do 10 multiplied by W, which is a negative. And then we can do plus, and also this is actually not really well, it's not really a true static question, but it is because of this effect here. This actually, you can treat this whole thing as one object, so basically what they're saying. But I like how they did it, no. Anyway, minus 60, right, as a plus, sorry. 60 multiplied by 30, uh, and then the 200 goes away, so equals 0. And I believe that's all you have to do, which basically means W equal, this goes to negative sign, so 1 divided by 10, negative again, so 60, 30. And then this should give you what the weight can possibly be. So 1 divided by 10 multiplied by parentheses 60 multiplied by 30 equals 180. So, wait, 180. Again, there's another mistake on this one. Well, we're finding like a bunch of mistakes on this. This is supposed to also be apparently 180, not something else. So womp womp D. I wonder if I did 0.2, I would have gotten their answer. So if I did 0.2 is 40, and then by changing the 60 to a 40, does it give you one? No, it doesn't. It's just wrong. Okay. So yeah, be careful about the wrong answers in here. There's actually quite a few of them. So if I were to say something, just check before you look at it. I'm checking all of them right now, so don't worry too much. I am checking badly over here because I know other people are going to use this, so I want to make sure it's semi-correct. All right. So if all right, we must do this part, but I think you might be a little bit confused over here because, it does get a little confusing up in here because you might think, well, how in the world is there a force here when we do a summation over here, F, and we do X and Y? There's no X over here in this rule. Now, here's the thing. This is classified as a pulley. And what did I say about pulley? They're transfer of rotation. So if I have a force over here going to a pulley, you can transfer the push to here. If I did like this. That's what's happening here. So this push and this push is kind of like that. Now, if you get that portion, now we can truly begin. Excuse me. So now you get that this is a really fancy pulley system. So in that sense, 10 multiplied by W, and it will be 10 because of how it works. And actually, because it's 80, right, 10, right? And then it'll be 30. And is this centimeters or is this in meters, actually? I actually don't know. Let me check. Oh, it is in centimeters over here. So these things are in cm, and these things are in cm. Those things are cm. So we have to make it into meters. So we have to say 0. You divide it by 100. So 0.3 multiplied by F friction equals 0.1 in weight. That is a key factor over here because of the transfer, and we all know how transfers work now because of the pulley system I've drained into you like 20 times already. So that means FFR equals 0.1 by 0.3 by weight, and weight is 80. So yeah, this is one of the harder questions. I don't know if FE exam will be this hard. This takes a little bit of a conceptual understanding to figure it out. I don't think it will be there. So 26.66 bar, but in any case, it's a hard question, in my opinion. So in that case, we go back to this bar graph over here, and we realize that the friction over here is 26.66 bars. Now, we know the normal over here. We know the normal is created by the friction. So we can go back to it. But we don't really need to do that, honestly, because we probably can solve it by just looking at the x direction. But if you want to do that, all the more power to you. You can do it. And you can get AY too. Basically, you can get R8X too. I think you can, yeah, you could definitely, yeah, I could definitely get to the normal force by saying mu because you only got mu 0 point, I forgot, 3 or something. You can reverse engineer it, but I don't think you need any of that because you are getting a normal force 100 over here, and you are getting this and a this over here with an A, and AX is what we're trying to figure out, and we just got the break over here. So in this case, wait a second. I think these are wrong because AX is equal to the opposite of that. So it is 27, right? It is opposite of the break. So what is going on here? It's going to the, yeah, I don't know what's going on here. It's going 27. Yeah. Um, and actually the break actually goes this way because it's opposite, so it's negative actually, sorry. But this is D. I think there's another mistake. This one had like 20 mistakes. So I wouldn't be surprised. Let me look at the original question. Yeah, yeah, the original question has it so that it is 27. I don't know where that extra one came from, but that one needs to disappear. Again, this is why I double check it, because if I double check it and my friends use this, they can still use it and not be scared for their lives that something's wrong. My friend's gonna totally use all of this stuff apparently. So I'm glad I'm the first one to make sure everything's correct. Okay, so the 285 kilogram plate is shown is suspended horizontally by 4 wires of length, whatever, and the tension of each wire is equal. If wire D snaps, okay, the tension of the three remains is redistributed. Determine the tension in each wire after D. Is this even a friction or is this a what? I'm questioning this because it doesn't feel like a. Well, it doesn't matter. So it's 285 kilograms horizontally, like this, right? And then we can do a moment analysis on this because right now we said TD equals 0. So right now we have something like, we used to have something like this to be stable, but now we don't. So we can do a moment diagram. And I think a moment diagram on one of these to figure things out probably is the best idea. And then a summation in Y. Yeah. Because right now the tension, so CY plus BY plus AY minus MG must equal 0. That is the summation of FY equals 0. So this must be true. That is a standard that must be true. And now we need to figure out one of the moments here. And we can actually figure out a moment because it's 3D by looking at something like this and doing a moment around here. And the right-hand rule says that's a positive direction. So in this sense, we can say the moment of MAB equals 0. Right? Doesn't matter where the moment is, it must continually be 0. And this allows us to get rid of A and B. So that means the force on CY multiplied by 8 meters must be equal, and that's the positive direction. And the negative direction is mg, which is 285 multiplied by 9.8 multiplied by 4. Okay, good, good, equals 0. Cy equals 1 divided by 8 of that, and it is 285 multiplied by 9.8 multiplied by 4 parentheses. So on 1 divided by 8 multiplied by parentheses 285 multiplied by 9.8 multiplied by 4 equals 1896.5, which I'm assuming is just 8. I think it might be just a little bit of a rounding error, as they say. Maybe they use 8.1 or something. And with that said, we can look at T, which one is this one? T, oh, we were using T format. Okay, TC then. TC apparently. So TC is, so this is wrong, and this is wrong. Okay, and now I could tell that it's going to be C because, oh wait, it could be C. We don't know yet. We have to actually check. I'm thinking it's C though, because how would you make B? Actually, maybe not. Maybe the, yeah, let me try something. Because I haven't actually done these questions before. So let's see if it's not that. Because I am not gonna say something. I already said like 200 things wrong today, so it doesn't really matter. So we're gonna do right hand rule, and this way is right. So we can do something like what do we do here? We do summation of CB moment equals 0. So in that sense, hey, wait, isn't it the same question? So this must be the same. So this and this is true. Oh, so it's B. Clearly it is just B because the same question we did earlier, just different placement. Yeah. And I like this one better. So let me just yeah. Ah, interesting. So in this case, normally you have these two forces because this is dead, this must also be dead. Consequently, because of how so they're coupled. I understand. But in reality, there's perturbation over here, perturbation over here. So this actually does something. But in theory, these two lines can carry all the weight. Wow. That is something I did not expect today. So that's a new information, wonderful information that I got from this. So I'm happy to know that. All right, a cabinet is shown weighing 110 newtons and is supported by wheels. Which is the following case yield the largest value of F? Which of the following case yield the largest value of F that will move the cabinet to the right? Um, Let me think about this. Okay, so this is doing something called rolling, right? So if this block is like this and you have force like that, if this is locked, you're having a force this way and this way. And if rotates freely is basically a roller. So this gets pushed, you're rotating. You're forcing a rotation. If this is locked, which is going to be something like this, then you're rolling this. So this is rolling while this is skirting along. So won't it create another moment here with the weight? I think so. I think I think it should create a moment. Imagining it this way actually, because it's gonna be Swiss force. So imagine this like this, and you're going to tell me that this is being pushed. You are pushing down over here, but there's no reciprocal force here, and mu equals 0.3. Okay, so here's the thing: when it rotates, it's going to create a force, right? Huh. So what is it looking for? Oh, that's just A. No brain, because this thing is going to help it rotate, and this is going to help it rotate. But if these two are locked, you're having a restrictive force on both. So it's obviously A. There's no question about it. You can do the math on that too, I guess. I'm not doing that. When something's doing that, I'm not doing it. Basically, it's just logic, right? All right, let's do this. Maybe not logic. I might be just fitting here. Anyways, we need to get this happening. We need to get find W, and the angle is not known. Okay, so we have this, and we have 45, and apparently it is an unknown angle, and it is theta. And this is going to go W, and this is going to get 2000. Okay, so we can just erase all this and just do it. So what's happening here is, again, these are frictionless. So you're just grabbing the force over here to 1000 newtons. And then you have an angle that is 45 degrees over here. We have another force over here that's 2000. And over here, you have a tension one that you have no idea what it is. And you just have to solve for that. Okay, so there is a question about the angle and a question about the tension. Well, this seems to be a job of the sum of forces equals 0. So if we have 1000 and we have a cosine of 45 and we have minus t1 cosine of some theta, that must equal 0. That is true. And now the second thing is a summation of fx equal to 0. You know why? Because this also must equal. So that means 1000 plus, and then it's going to be sine 45, and then it's going to be plus t1 sine theta minus 2000 equals 0. And now we know t1 uh, equals cosine on the bottom, and then it's negative, negative, so 100,000 cosine 45, and then we move it over here, so we have 1000 sine 45 plus 1000 cosine 45 divided by cosine theta sine theta minus 2000 equals 0. Then this is 1000 sine 45 parentheses plus 1000 tan theta cosine 45 minus 2000 equals 0. So we can do 1000 sine 45 parentheses plus no, not plus, minus 2000, and then we divide that. I'm not making any. Uh, we're not doing anything bad. So it's 1.129. Go to the other side, and then it's arctan. I think I forgot the divide by cosine. Uh, yeah, divide by cosine 0.5 parentheses. Okay. And that should give me that, I guess. And then it gave me tan e wait, it gave me tan theta equal 1.828. So you just do tan inverse of that. Not Yeah, tan inverse of that. And we we get negative, oh, not negative, 61 degrees. So this is 61 degrees. And with that 61 degrees, you can plug it back into here. So divide by 1000 cosine 0.5 parentheses divided by cosine, once again, 61 point something, 32 something, 324. I mean, it's not, we'll just call it 61. We can call it 60, it won't matter. It's about 15,000, 1,500. I had to round it up, but yeah, that's usually how it works with these questions. They round up to the second digit, so it is C, in my opinion. So over here, we have another question. A block with mass of 150 kilograms is pulled over a horizontal surface and cable guide the fixed sheath as shown. The coefficient of friction is 0.58, and I'm actually going to double check that because I know from last time that it might be wrong. Oh, it's right this time. 0.58. And between the surface is zero point 0.9. That's all correct. Okay, we don't have to worry about that this time. And what force F must be applied to the cable for the block to move? Now this is using force 1 equal force 1 E mu. I believe it was mu, right? Let's see if I was correct. Where is it? I don't see it. Here it is. F2, sorry. F2 mu theta. And you might be wondering, okay, so what does that mean? Well, from experience, you're supposed to get t over here, and then you're supposed to multiply. So t, so f equal, yeah. So you can call it, yeah, t2 e mu theta. From experience, you're basically pulling it out of the grave. Yeah, and this is t2 and this is f. So what's happening is that you are getting, well, now on force side, you're multiplying whatever you have outside, and you're multiplying by e mu theta. Yeah. And this is what we have to discuss. But this is T2 and this T2. That is the conversion factor. But T2 and this is a different beast. This is 150 multiplied N. And what force must you apply for a cat to move? So you're going to do not newtons, is 9.8 multiplication, and then that turns into 150 multiplied by 9.8 equals 170, and then it's going to be mu, so it's going to be multiplied by 0.58, which is 8. So the friction force is 852.6, and then that will be plugged into here, and 60 pi 180. So division 60 pi 180 equals pi over 3. So 1 point to that. So E, where's E in this equation? And that is e to the 1.0471955 multiplied by mu, which is 0.9, which is now 2188, which I'm going to round up to C. So C. Yeah, I think that is correct. Can you move on now? What is the total torque is applied to the pulley? Okay. In this case, when it's 2200, I'm assuming, right? Unless it is not. I think there's an equation for that. Oh, they don't give you it? Oh God. Okay. So here's the torque. Okay. Um, the torque is equivalent to saying for these questions F max minus F min, parentheses R. I'm shocked that they don't give you it. Which means this is a legal question. Basically, it's not going to show up. This is by far a mean question because it's not showing it. Okay, so that was an interesting squabble. Check out your thing. I don't know why they wouldn't give you it, but I will also give you this equation over here where there's a tangential velocity power equals, I hope they don't give you this, but it's F1 minus F2 parentheses V velocity tangential. Yeah, I don't know what's going on. And the way you do it is basically the T1, T2 is this one, T1 is this one, and then basically that tells you everything. So in this case, we have F as here, and we have F2, which is T2, and this is T1. So in that case, T1 was about 2200 and was minus by T2, which was 8 something, I believe, in the calculator, 852. And then over here was multiplied by D divided by 2, which 35 centimeters divided by 2. So it is 2200 minus 852. And then it will be multiplied by division factor of 35 divided by 2, which is, I think, B. It has to be B. I'm getting B as my answer, and I hope that's correct. But this is like a bullshit question because you have to know something that is not known in the give out sheet. So I don't like this question. I actually detest this question. This question shouldn't have existed, in my opinion. Okay, next question. What is the tension in cable AB? Okay, AB. All right, we can do that. And it is this equation over here. So basically what's happening is this is like this, and then we have this over here, and we have this over here. And over here, we can see this is going to be 60 degrees, and this is going to be 30 degrees. In between, there's something. So here's something I'm going to do something special where I'm just going to, I was going to couple these two. And I think I can still couple them because over here, we need C, and we need C to D, so force CD and force BA, right? And this is 500, 500. We can, I think we don't need a moment here, right? Summation of fx, and then we can figure this out, right? Is what my thinking was. But I might be flipping here, and I might be flipping here. Let me check something real quick. We need A and B. So we need this portion over here. We need this 60 degrees over here. We have 500 over here. We have this over here. I think we can just do this. I think I could do the summation of fx equal 0. And we can do FBA. And then we can do cosine, no, sine for this case, I guess. And we minus direction. Sine 60. And then it would be minus, it would be plus. This will be force BC plus force BC, and it'll be sine of this angle over here, which we know this is 120, this is 180. Then this over here, from this angle over here, 120, this must be 120. So this over here, 90 degrees from here. So 120 minus 90 is 10, 1, 3. So 30, sine 30. No, it's not sine 30. It is cosine 30 because of how it's written. That equals 0. Okay, that's one formula down. We need the second one, which is the summation of Fy equals 0, which is minus the plus FBA cosine 60, right? Plus FBC sine 30. And then you have a minus 500 equals 0. Correct? Okay, so now we have all this, and I think the best way to do this is actually go to your calculator and there's a system function in there. And then with that system function, you can type all this in and do this. I believe you press on and go to the system, 2 by 2 linear solve, and then we do minus sine 60, and then we do cosine 30, parentheses that, we do 0 on the end, and then we do cosine 60, and we do sine 30. I'm gonna do it, I might do it by hand just for fun. But if I was on the test, I think I should be using this, and I get x equal 500, so it's C. The answer is C. But if I was on, that's because I would have done that with the non-test version because even in your allowed calculator, there's a system function you can use that allows everything to be easy. Sinder, you should be able to get this by looking at this and just saying it's. Hmm. Anyway, it is C definitely. All right, next up is this question. What a 2 kilogram box with a incline of 34, if the coefficient is 0.2, which I don't trust it. I need to double check if the number is correct. It probably is, although yeah. If the coefficient separation is 0.2, how much additional force F must you apply to keep the block from sliding down? Well, this is a classic question about just figuring out the right angles. So over here we have this, right? We have this mg, which is basically this. We will be using that as the focal point. You're gonna have to get this force over here, right? And basically that is Ooh, you're trying to make it not go up. Okay. So first off, you have to do is notice that mu is only in effect if friction's gonna be effect, definitely, but a lot of times only if the motion it is something is imbalanced, and we're gonna use the max of that to be helping the human do F force, right? So in this case, you have the sign, so it's gonna be W sine, it's gonna be summation of Fx first, which is gonna be in this direction. It's gonna be X and Y. Sine, whatever 34 is, we just move over there, plus mu friction, right? And then actually it's gonna be minus. And then, I mean, technically it is minus. So, well, it depends how you look at it. This is actually minus over here if we were to do, wait, what am I doing here? I'm doing the summation of x. So this is correct. And then we can do minus direction because it's actually moving this way. And then this is a positive direction because it's going to make a friction that way. And then we're going to do another positive on the force equals 0. So F must equal mu sine 34 minus mu n. Okay. And n is equal to saying summation of F, y. So if I were to do that, n is the normal plus mg cosine, because this is the cosine. And then this is cosine 34 equals 0. And then n equal negative mg cosine 34, if I remember correctly. Am I wrong? Yes, I am wrong, because this is a minus, so this is a plus. So yeah, this is a plus, so we can do this way. And something was definitely wrong about that. So 2 multiplied by 9.81 multiplied by cosine 34 is about 16. 16 is Newton, so then it's multiplied by 0.2, which is about 3.2. The weight of the block is 2, so 2 multiplied by 9.81 multiplied by sine 34 is about 10. So 10 minus 3 equals 7.718. So it is A. Good job. Okay. All right, the cylinder shown is acting as a couple M. Wall A is frictionless, all right. And but the coefficient of static friction between the cylinder and wall B is 0.3. The cylinder has a weight of 0.200. Okay, so probably B. Okay. What is the largest value of the couple M of which the cylinder will not turn? Okay. Um, that's an interesting question to give. Definitely not normal. Makes sense. Um, Okay, so we'll be doing that. I think how it's done is that we have to convert the moment into basically a force, right? So let's do this one. Let's do this. So there's a normal force this way, there's a normal force that way, and there's a friction force that way, and there's a 200 over here, and there's a moment over here. Okay, the 200 thing doesn't really do much for the moment. But this point over here definitely does something with the moment, but the perpendicular lines do nothing for the moment. But we need to figure them out to figure out the sum. And according to this, we have normal 1, normal A, normal B, and no A. We have a friction over here, which no, an unknown moment over here, which we have to figure out. So there's a few unknowns over here. So I would begin with probably, how would I begin this actually? Um, hmm. NG is a reaction force. Well, I think the first logical way to do it would be to figure out what weight is, what the Fy is, because the friction does Fy, and the friction does Fy, and the normal force does Fy, but no other place does Fy, right? And friction is definitely going to be equal to mu S and B, right? So let's just do summation of Fy equals 0 over here. So in that case, well, we have to count to 200 then. That wouldn't be really helpful, will it? Well, maybe it does. So minus 200, okay? And then we need this angle over here, which is a 3, 4, 5 triangle. So we can do cosine and yeah. So plus FFR, and we need this sine version of it, sine theta. And then we need to do plus NB, and we need to do the what version of it? We need to do the, which one's angle to the Y? So how do you want to do the theta over here? I want the theta this way maybe, so sine alpha, we'll do alpha and theta. So that would be, that'd be cosine. Cosine alpha equals 0. Okay, we can do that. We can definitely do that. We can work with that. Over here is minus 200 plus mu s n b, and then we can do sine of theta, which is a 3 4 5 triangle. So we can do 5, and then we can do 3, right? Plus nb cosine. And the cosine is actually, fun fact, because it's perpendicular, we can actually assume it's 4, 5. Why? Because of how it works. If you're going to flip it, you can figure out because of how, if you flip these two, you get the perpendicular version of it, is what I remember from back in the day. Equals 0. So in that case, actually, we can solve for n over here. And is there a way to do polysolve here? Yes, there is. There's a polysolve over here, and we can solve an x square version. Okay. I'm not sure if we need an x square. So actually, I'm just gonna do it by hand because I think solving by hand probably is easier than doing this stuff I'm trying to do. How do you second clear? How do you quit? Oh, I don't know how to use my calculator. Okay, second quit. Can you clear this? I don't understand why. Okay, second off, on. Okay, normal calculator. All right, I'm just going to do it by hand because it's much easier for me to figure it out. So it is 200 to the other side, right? And then it's equal to 1 plus 3 divided by 5 by 0 0.3, and it's going to be NB. NB equals 200 divided by that. So if I do 200, and then we do multiply by divide by 1, parentheses, 0 0.3, multiply, divide, 3 by 5, plus 1, then we have 1, 6, huh, that doesn't sound... So 200, did I do this right? Oh, shit, I forgot the 4 divided by 5 over here. All right, divided by 4, divided by 5. All right, 204, that sounds okay. 204.1, that's what we get. And from that NB, we can now figure out everything because you asked for what's the largest M. We have MB now. We have 204. We have friction, and now we can figure out anything else you want, basically. Because think about it. I didn't realize that if you have a normal force, you basically have one equation, which is wonderful. But we have friction force, which is basically 0 0.3 version of this, 0 0.3 multiplied this. So we have 61.224 newtons over here. So basically, right now, we have this, and now we just need this to complete our perfecta. But if I create a moment on A, we can just delete that if we want. Exactly. But it doesn't matter because it is aligned with this. So just create a moment on MO equals 0. It should be good enough. And then moment at FO, we know the friction matters. Friction multiplied by 0 0.5 to be exact, which is the positive direction, plus M equals 0. So we could do the minus M or positive M, depending on how you do it, lots of value of couple, whatever. It could be, so 61 multiplied by 0 0.5 is about 30. And that is how much you can do. So 31 probably, because it's 30.6, they rounded it up probably. So it's A. That's actually a hard question, generally. That took a long time to do. Over there, next one over here, we have a rope pass over a fixed sheave as shown. The two rope ends are parallel. A fixed load on one end of the rope is supported by a constant force on the other side, and the coefficient between the rope and the 0 0.3 was the maximum ratio of the tensile force of the rope. Okay, so what? Okay, that was a what question. Like what? Um, I think this is saying you're supposed to use mu data, and we know data is actually 180 pi over 180, so it's equal to pi. So this is e to the mu pi, and I think you want f1 over f2 equal this or something like that, something a little bit spicy like that. Okay, so I think then it is probably e this power of 0 0.3 multiplied by pi, which is about 2.56. So it's d. Um, Generally questioning what the hell is going on with this question. I mean, it's a fun question, but I don't think it just tests anything. What's the maximum ratio of tensile force about in between the two worlds? Okay, that could have been worded so much better. I don't know why they chose to do it that way. Okay, in this equation, I believe there is. I'm pretty sure it's using this. Now this, I've never been taught this before. So the nut on the collar are each tightened at 18 newtons per meter. 17% of the torque is used to overcome the slow thread friction. The bolt has a nominal diameter of 10. The thread are a simple square cut with, okay, blah, 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 with the 0 point thread. Coefficient, what's the approximate? Okay, with a 15 pitch. Okay, we got it. So earlier I said, basically, that M equals PR tan alpha plus alpha, right? So first thing we do is alpha equals arc tan mu. And that sounds counterintuitive. You have to look over here. This is what you're trying to say over here, right? So We can get that portion out of the way. So mu was what was it? 0.1. So tan inverse is 0.1. So that's about 5.71059. And I think this question is bullshit, but we move on and we still do it. The moment is basically 0.17 times 18. We don't need a full explanation on that one. And then R is basically and P, what was P again? P is what we're looking for, right? P is the load, yeah. P is what we're looking for. So P equals M divided by R tan, and then it's 15 threads, right? Plus 5.21071 or whatever. 7, I think it's the 7. Yeah. And then this is how you get it. And then R equals basically whatever the diameter was, 10 diameter, 10 millimeters, divided by 2, which is what we have over here. 10 millimeters is 10, so 0.201, I believe, divided by 2. So what you have in the end is 0.17 multiplied by 18. Down over here is division. 0.01 divided by 2 multiplied by 10. Parentheses 15 plus 5.71059 parentheses. And with that said, is about 6126118, but it's gonna round up to 2 because that's how they always do it. So it's D. This question is bullshit. All right, we're doing this question, and then the height over here is 0.5 over here. With that said, this FAE is 0 because from last time we figured out if there was no second trough, this actually does nothing. Because if this was doing a force, what would happen to this little plank is that it would either move this way or rotate down way. So yes, if it's dynamics and there's like a vibration and that happened, then it will swing, yay! But we're not dealing with vibration or dynamic equations. We're dealing with statics. Okay? Get that through your head, first of all. Secondly, we're going to do something called, because of that, we're going to simplify this into a 2D question. We love 2D, and we always love going to 2D. So we need this length, which is basically doing the Pythagorean theorem. Let me just do that real quick in my calculator. 0.6 squared plus 0.4 squared equals about 0.7211. Okay, so if I do it like this and do the Pythagorean theorem with the half of that, so divide by 2, and then square that plus 0.5 square, and then second square root of that thing, we get about 0.6164 415. Notice something. This is like a pulley system. So this rate in total must be this rate. If we look at the global scale, what that means is that instead of doing it the hard way with all moments, we can instead treat it like this, a force like that. What does that imply to you? Well, that implies to me that I can get something called a summation of Fy equals 0 here. So that would mean we have a full upward direction instead. We treat it like a reverse question. And we do 600 as the plus this time and minus everything. And then we do theta, right? So we can do a few different things. We can use sine. We can use sine. We can use cosine, sorry. We can use cosine to justify this, which is a good idea. So we can do T1 cosine and theta equals 0. 2. So what that tells you is T1, we know this is 0.5 on the top and 0.61644, which equals negative, which now turns to positive because we multiply negative. And you can kind of see where I'm going with this. So similarly, in each case, we can now just divide this by 2 also. So it's tension 1 equals 300, and then multiply by 0.61644 divided by 0.5. So this becomes 300 multiplied by division, 0.61644 divided by 0.5, which equals 369.8. So we can take this as a C as our answer. If you did it the hard way, then kudos to you. This question becomes impossible. There's a way to do it with moments, and let me just tell you that if you did it that way, this question like literally is a waste of time. Like this is a hard question that you can't solve, literally. I mean you can solve it, but it's gonna take forever. Anyways, okay, we're doing this question now, which is a rope. The rope is wrapped over a 6 centimeter diameter pipe to support a bucket of tools being lowered. The coefficient of friction is 0.2. The combined mass and bucket of tool is 100 kilograms. What is the range of the force that can be applied to the free end of the rope that the bucket remains stationary? So this is another power graph, power, whatever, of F1 equal F2 E mu theta. Now imagine this. Imagine for a second where the force is coming from. This is a force, so we have a tension over here, and then we move over here. So T1 is over here. E, and it's going to be 0.2, and then it's going to be theta, whatever theta is. I don't really know what theta is right now. Equal F1. F, all right. I don't, that is kind of the relationship we have right now. Okay? Now the question is how to figure out the other stuff with the degrees. So originally we had something like this if we were doing a 90-degree, right? But we're adding an extra 20 degrees here. So what that really means is that we just added 20 degrees to 90. So we added 20 degrees over here. So we added, so theta equals basically 90 plus 20 equal 110. And that's pretty much it, but it needs to be in radians. So it's multiplied by pi over 180. And that is what's going to be in there. Okay? And what is the range of the force that can be applied to the free end of the rope. Okay, so now we put that into the perspective bucket. So it's a 1,100 kilograms, so multiplied by 9.8. Okay, multiplied by, because this is T1 equal, what's this? 100 multiplied by 9.8 E 0.2 multiplied by 110 pi over 180 is what we're doing right now. So what we have to do is basically EE, power over here, in parentheses, division by 110, and then we do pi, divided by 180, which is parenthesized to equal, whoa, that's a huge number. I think I made a mistake somewhere. Yeah, definitely somewhere a mistake will happen. 91, point minimum tension. What's going on here? Um, let me see what I did wrong here. So over here, we found that the answer is, for now, let's do T1 over T2 over like this, which if I did that without it, it is basically, oh, wait, I forgot the 0.2 over here, actually, multiplied by 0.2. Okay, that equals 1.46. Okay, so maybe it's because I forgot the 0.2. Well, that is 1,000, well, 1,000, 44. So it's about this height over here. And now that means it's B. So I was right. Let's do it. Okay, so it's B. It was right, the original method. I just fumbled the numbers for the 0.2. Over here, there is two cable carrying the vertical load. What is the, well, how do you get the minimum? Is it the opposite way around? But okay, so, oh, I only did the F end, but the other one is talking about the right end, because if you were to make a function out of this, it would be something like starting at the 670 newtons, and it will go all the way exponentially probably to 144. That makes sense. And basically, the whole idea is 0 to whatever this is, which is 110 degrees. It will show that function going up and be exponential, basically. It'll be a simple exponential that you will see, and that should be how you get it. How you get how what it's telling you, basically. Which is a beautiful way to say, yes, I get it. Okay, so over here, this is A. This is over here. This is over here. This is 100 newtons over here. We're trying to figure out AB. So these angles should be the same. No, no, no. This over here is 3, 4, and okay, that makes sense. Okay. So summation of fx equals 0 is basically saying FAC cosine of theta, this is positive, and another one is a minus direction, FBAB cosine of that direction equal 0. And this is going to be FAC, and it's going to be 5 on the bottom, and it's going to be 3 and minus what was it again? AB, and it's going to be 4 over 5 equals 0, right? I'm going to use a calculator to actually simplify very fast. I'm not doing it by hand again. Fy equals 0, and this is going to be 1,000 minus, and it's going to be plus FAC sine theta, and then it's going to be plus FAB sine theta 2. Sorry, this should be 1 and 2. I don't know why I didn't do that, but I'm so used to just not doing that, so it doesn't matter. Okay, so this over here should be 4 over 5 and 3 over 5. And with that, you can plug it into your calculator to figure everything out. And I'm just going to do that real quick. Second solve, linear solve. And I'm just going to do what I just said I'm going to do. 3 divided by 5, negative 4 divided by 5. It's going to be 0 on the other side. Okay, and then this one is going to be 4 divided by 5. And over here, it's going to be 3 divided by 5. And it's going to be 100 on the other side, which we can solve. And we get x equal 80 and y equals 60, which means this over here, what we're looking for, AB. So it's 60. C. That's what I got. I hope you got the C too. Yeah, because that's what I got. Okay, we're moving on to this one, which is 12, which is also one of these problems. Power pass over a stationary sheave, and supports a 60 kilogram as shown. The coefficient of friction between the cable and the sheave is 0.1. The cable has a uniform mass per unit length. Uh, why would you do this to me? Why? Okay. You're just putting pain to this equation. The cable has a shape of a static ratio its own weight. The tension of the wave is given by T delta Y, where Y is the weight per unit and the constant weight. And how much more mass can be added to a buffer before the cable like destroys itself? Okay, this is just bullshit. This is just prime state bullshit. And this is plus pi divided by 2 over here, which is what is it? 0.197 plus pi divided by 2. Clear, clear, clear. 0.197 plus pi over 2 is about 1.7677. Okay. And then we have WY is how we go, which is basically saying MGY. So the tension is a fixed end of the cable is this. Yes. Which is 0.4 multiplied by 9.8 multiplied by Y, which is 20. No. What's Y? 20? These 20. Which is interesting. Um, but yeah. Okay, is oh wait, that's not 20. It's 151, which means this is 591.92 for my calculation. We also need F1 divided by F2 like last time, which is equal to E mu theta, which is equal to saying E 0.1 with 1.7677. So we can do that one. With that said, hmm, we can calculate that and we can get to certain values. E to 0.1 multiplied by 1.7677 equals about 1.193. And this is powerful because you have the tension of the cable is given by this as max. So we can multiply this to the friction to get the required thrust to do everything. So 591.92 multiplied by this value is 706 0.37. Okay. So what it's saying is right now we have 60 multiplied by 9.81 also, which equals what? 60 multiplied by 9.81. So it's a difference between these two now because the maximum amount we can get is 706. So 706 minus 702 equals this, 1, 1. So if I multiply this two, it gives me 706.37. If I minus 706 minus 588, that gives you 117 newtons. And if you divide that by 9.81, it should, in theory, give me the right value. And I got 12. I didn't get 12.1, but I got 12, which I'm guessing is some kind of rounding error I made. I'm just gonna assume that. And oh, we're done with the pulley section. Okay.